This video we are going to see how to convert binary to gray code, that means binary to gray code converter. So we all know the binary numbers, so we are going to design for 3 bit means b0 b1 b2, and 3 bit means how many combinations? 0 to 7, correct? 0 to 7 combinations. So we all know how to write the binary number, that means always just for 1, 2 and 4. Now write the binary number for 0, that is 0 0 0, for 1 which is 0 0 1, for 2 which is 0 1 0, then for 3 it is 0 1 1, for 4 it is 1 0 0, 5 it is 1 0 1, 6 it is 1 1 0, and for 7 it is 1 1 1. So this is binary number for 0 to 7. We already know how to write the binary numbers. Okay, so now we have to convert this binary number into the gray code. So that's why I have written here binary are the inputs, and what are our outputs? That is the gray code. That's why I have written here gray outputs. So my 3-bit binary number and 3-bit gray output. So how we can write? So there is a method, that means what is the method? Suppose for example we have to write the gray code for the first, for 0 0 0, that means for 0 0 0 we have to write the gray code. So how we can write? I'll just show you. First write your number, that is 0 0 0. What we'll do is write first number as it is, that is 0 0. Now do the XOR operation, that means 0 XOR 0. What is 0 XOR 0? We all know that is 0. Then again do 0 XOR 0, that is what? 0. So as we all know the truth table of the XOR gate, what is that? That is 0 0 0 1 1 0 1 1. For these inputs, XOR gate is a odd one detector, that means for same input it gives the output 0, and for odd ones it gives the output 1 1. So this is the XOR gate. So for 0 0 binary number we have get the same gray code, that is the 0 0. So write it here 0 0 and 0. Now we will see the second example. If you want to write the gray code for example second means for this one, for 0 0 1. So take an example of 0 0 1. Now again process is same, write first bit as it is, then again do the XOR operation. That means 0 XOR 0 is, we know that from this XOR gate table, that is 0. So write it 0 here. Again 0 XOR 1. So what is 0 XOR 1? Here 0 XOR 1 is 1. So here we have got the 1, right? So what is the gray code for 0 0 1? Write it down, that is 0 0 1. Now we will see this another example, that is for decimal number 2, 0 1 0. So again take the example of 0 1 0. So you can take here example 0 1 0. So first bit as it is, do the XOR operation of these two, that is 0 XOR 1 is 1. Again 1 XOR 1 is 1 XOR 0 is 1. So what is the, this is the decimal number 2, binary number 2, and XOR or gray code of the number 2 is 0 1 1, that is 3. So write it here, that is 0 1 1. So you can do for the next 3 4 5 6 7 like first bit as it is, and do the XOR operation of the remaining, that means 0 XOR 1 which is 1, 1 XOR 1 which is 0. So the binary number 3 or decimal 3 has a gray code 0 1 0. Now for 4, 1 bit as it is, then 1 XOR 0 it is 1, 0 XOR 0 it is 0. Again for this number, first number as it is 1 XOR 0 which is 1, 0 XOR 1 which is 1. Now again 1 as it is, 1 XOR 1 0, 1 XOR 0 which is 1. Now 1 as it is, 1 XOR 1 which is 0, 1 XOR 1 which is 0. So we have just got the truth table for binary to gray conversion. So this is our binary inputs and this is our gray outputs. So now we will write the minterms from this truth table. Minterms means the binary number for which the output is logic 1. So first we will write the G0. So you can see here we will write the minterms for G0. Okay, here minterms for G0. Okay, so minterms for G0 you can see here in G0 column output is 1 for 1, 2 and 5 and 6. So minterms for G0 are 1, 2, 5 and 6. Just write it down, that is 1, 2, 5 and 6. So for this 1, 2, 5, 6 we have got the output 1 for G0. Now we will write the minterms for G1. So again you can see in G1, you can see here in G1 the output 1 for 2, then 3, then 4 and 5. So 2, 3, 4, 5 are the minterms for G1. So just write it down, 2, 3, then 4 and 5. Now write down the minterms for G2. Again here you can see in G2 column, here G2 column 4, 5, 6 and 7. 4, 5, 6, 7 are the minterms. That means output is 1 for that particular number, 4, 5, 6, 7. We have just seen the binary to gray code converter and we have seen the minterms, that is G0, G1 and G2. So if you see in truth table, minterms for G0 are 1, 2, 5 and 6. We have already written here. For G1 that is 2, 3, 4 and 5. We have already written here. Then you can see the minterms of G2, that is 4, 5, 6, 7 is equal to the minterms of B2, that is 4, 5, 6, 7. That's why for the 4, 5, 6, 7 G2, we can write G2 equal to B2, because you can clearly see here G2, this G2 is equal to B2. So now we are going to see how to draw the circuit diagram of binary to gray code converter using the IC 74138. As we all know, IC 74138 is a 3:8 decoder IC. In that we have 3 inputs and 8 outputs. So you can see here pin configuration. You can see 1, 2, 3 are the inputs. So what inputs we have, that is B0, B1, B2, because it's a binary to gray. That means binary inputs are the inputs and gray are the outputs. So you can see here I have written here B0, B1, B2, that's our input. Then 4, 5, 6 are the enable pins, that is 4, 5 is active, that's why connected to the ground. 6 is E3, which is active high, connected to VCC. Then it is 16 pin IC, that's why 8 is ground, 16 is VCC. Now we have to draw this we have to draw the circuit for the binary to gray code converter. So first see the minterms. So in IC 74138 Q0 to Q7, these are the 8 outputs and pin numbers are 15, 14, 13, 12, 11, 10, 9 and 7. So how we can draw the circuit? It is very simple to draw the circuit diagram, that is you just have to connect these minterms. Now you can see we have used here 4 NAND gates and 2 OR gates. Why NAND gates? Because these minterms we have to connect it to the output pins, and output pins of the IC 74138 are the active low pins. Okay, so how we can draw? So we have taken the 2 input 4 NAND gates, because we are going to use the IC 7400, which is quad 2 input NAND gate IC. That means this IC contains the 4 NAND gates, and we are going to use the IC 7432 for the OR gate IC. So this is also quad 2 input OR gate IC. That means this IC contains the 4 OR gates. So how we can connect? You can see here G0, for we will see first for G0. So G0 min terms are 1, 2, 5, 6. So as we are using 2 input NAND gate, so these 2 min terms as a input to the first NAND gate. So what is the first 2 min terms? 1 and 2. So just connect Q1 and Q2 to first NAND gate. Then next is the 5, 6. Just connect Q5 and Q6 to second NAND gate, and this sum of these two is your G0. Now for G1 you can see again 4 min terms. That's why 2 NAND gates, 2 input, 2 NAND gates. So 2, 3, just connect this Q2 and Q3 to this NAND gate, and again 4, 5, just connect Q4 and Q5 to second NAND gates, and this summation of this to the OR gate, that is your G1. So this is G0, G1. Now G2. For G2 we have written G2 is equal to B2. So you just take this B2 from here, and this is your G2. So this is your IC or circuit diagram for the binary to gray code converter using the IC 7438. And we will see how we have given the numbers like 1, 2, 4, 5, 6, 9, 10, 8, 12, 13, 11, these numbers. So for 7400, that is 2 input quad NAND gate IC, there is a standard pin configuration. This is the standard pin configuration. So this IC consists of 4 NAND gates, and each have the fixed number, that is 1 and 2 input, 3 is the output, 4 and 5, 6 is the output. Then 10 and 9 input, 8 are the output. So you can see I have given like that: 1, 2, 3, 1, 2 input, 3 output, 4, 5 input, 6 output, 9 and 10 like this. 9 and 10 input, 8 is the output. So you can see here 9 and 10 input, 8 is the output. Same for the OR gate IC, again 1, 2, 3, 1, 2 input, 3 output. So you can see here 1 and 2 input, 3 is the output. For second OR gate, 4 and 5 input, 6 is the output. So just write it down: 4 is the 4, 5 input, 6 is the output. So likewise you can give the pin numbers. So now we'll see how we can implement this is using the IC digital trainer kit using the IC 74138, 7400 and 7432. Now we will see how to do the connections of binary to gray code converter for 3-bit, that means 3-bit binary to gray code converter. How we can implement this is on this IC using this digital IC trainer kit. So we have used, you can see the pin configuration here. We are going to use 4 NAND gates, then 2 OR gates, and we all know the min terms for G0, that is 1, 2, 5, 6 from this truth table, and G1 min terms are 2, 3, 4, 5, and as you can see in this truth table, G2 min terms, that is 4, 5, 6, 7 is equal to the B2. That means G2 is equal to B2. That's why I have written here G2 is equal to B2. So you can see the pin connections. Okay, so first we'll do the VCC and ground for the IC 74138, then NAND gate IC, that is 7400, and OR gate, that is 7432. So first do the VCC ground connections. So here this is the IC 74138, this is 7400, and this is 7432. So this is the 16 pin IC. NAND gate 7400 is 14 pin IC, 7432 is also 14 pin IC. So for 16 pin, 8 is ground, and 16 which is connected to the VCC. Okay, now again for NAND gate IC, 7 is for ground, and 14 number is for VCC. Okay, now for 7432, 7 number is connected to the ground, and 14 number is connected to the VCC. So here VCC ground connections are over. Now we will give the input. So as binary to gray converter, inputs are binary number 3 bit B0, B1, B2, and outputs are G0, G1, G2. So first we will give inputs. So you can see in pin configuration 1, 2, 3. Pin number 1, 2, 3 are the input. That is in our case B0, B1, B2. So take a pin number 1, connect it to the input side. This is my B0. Now pin number 2. This is my B1. Then pin number 3, that is my B2, connected to the input. Sorry. So this pin is faulty. So just take another one. Connect pin number 3, which is my B2, to the input section here. So this is my B0, B1, B2. Now inputs are over. We will give the enable pin. 4, 5, 6 is the enable pin. In that 4, 5 are active low. That's why connected to ground. So take 4, connect it to the ground. Then take 5, connect it to the ground, and E3 is the active high enable, that is connected to VCC. E3, that is pin number 6, connected to the VCC here. Okay, now enable pins are over. Now we will connect the outputs, that is Q0, Q1, Q2. So in output you can see Q0 no connection. So from Q1, Q2, that is pin number 14, 30 is connected to the NAND gate of 1 and 2. So take a pin number 14. This is 14, connected to the NAND gate ICs, pin number 1. Take pin number 13. Take pin number 13, connected to the NAND gate IC, pin number 2. Then output of first NAND gate is as an input to the OR gate. So pin number 3, first NAND gate output is connected to the OR gate IC. This is our OR gate IC, third one, connected to the pin number 1. Now second NAND gate. Second NAND gate you can see pin number 10, connect to the 4. Pin number 10, 9, 10, connect to the pin number 4. Then pin number 9 connected to the 5. Pin number 9 of the first IC, which is this 9, connected to the NAND gates ICs, pin number 5 here, pin number 5. Now take output of the second NAND gate, that is 6 number. This is 6 number, connected to the OR gate of pin number 2. Now output of first OR gate, that is pin number 3, connect to the output side, which is our output section G0. So this is my G0. Okay, now for G1 you can see here pin number again 13 is connected to the 9. Pin number 13, that is you can see here 16, 15, 14, 13. So pin number 13 is connected to the pin number 9, which is here 8 and 9. Now again pin number 12 is connected to the 10. Pin number 12, that is this pin number 12 is connected to the pin number 10. Pin number 10 is like 8, 9 and 10. Now output of second NAND gate, that is pin number 8 connected to the OR gate of 4. Output 8 here, output 8 is connected to the pin number 4 of the OR gate IC. Okay, now last NAND gate, you can see here pin number 11 is connected to the 12. Pin number 11 of the first IC 74138 connect to the pin number 12 here. Now you can see pin number 13 is connected to the pin number 10. Pin number 10 is connected to the pin number 13. Okay, and the output of this NAND gate, that is pin number 11 is connected to the 5. Pin number 11 connected to the pin number 5, and output 6 is your G1 connected to the output section. So this is my G0, G1. For G2, you can see here G2 is equal to B2. So input B2. So this is my B0, B0, B1, B2. So input B2, take input B2 and connect it to the output section. That is my G2. So this is G0, G1, G2, and this is my B0, B1, B2. So all connections are over. Now we will see the output. So for output for G0, you can see 1, 2, 5, 6, but 1 is present in only G0. So only G0 should blink when I will apply the 1. So apply 1 here, 0, 0, 1. You can see here only G0 blinked. Okay, now minterrupt number 2, you can see minterrupt 2 is present in G0 as well as G1. So this G0, G1 both. Now we will see the output. So you can see G0, G1, G2. One minterm 1 is only present in G0. Just give 1 and you can see only G0 is blinked. Okay, now give minterm number 2. Minterm number 2, that is 2 is present in G0 and G1. So just give here at input 2 and you can see G0, G1 blinked. Now give minterm number 5. 5 is present in G0 as well as G1. So just give 5, that is 5. You can see, and 5 is present in G0, G1 as well as G2. That's why all three G0, G1, G2 are blinked. Now minterm number 6, which is present in only G0 and G2. So just give 6. You can see only G0 and G2 blinked. Now give minterm number 4. 4 is present in G1